This lesson is utilizing callbacks for asynchronous JavaScript. The objectives for this lesson are to grasp the idea of callbacks, examine an example of executing a callback function, supply data to the callback function, develop asynchronous callbacks, and manage multiple callbacks including success and error handlers. Callbacks are nothing more than functions that can be passed to another function just like you pass variables in. A function receives the function argument as a named parameter. That function is then executed by putting parentheses after that parameter name. Data can also be passed to that callback function. Let's take a look at invoking our first callback in JavaScript. In this web page, in our script, we have a call on line 25 to call getMovieData, and we're passing in an argument, but the argument is actually the name of the function movieSuccess. If you look down on lines 37 through 39, you see that movieSuccess is indeed a function. You make sure you do not use the parentheses in line 25 because what you want to do is pass a pointer to where that function resides in memory. On line 29, we accept this function pointer to call, and we're going to call it function to call. And then we're going to actually invoke that function by simply using that parameter name that came in, open, close parentheses, and that then makes the call at that time. And we'll see this because if on line 29, we're going to pass in that function to call, we're going to, on line 30, do a console log getting movie data, and then we call function to call, and then you'll see movie data retrieved. So let's go ahead and try this out in our browser, and there we can see our two values, getting movie data retrieved. So if we come back over here, we can see, yes, indeed, that was the order in which we expected things to happen. So I guess the question is then, what would happen if we did this? If we were to put the open close parenthesis, it's going to call movieSuccess first because this says make the call and then return whatever and pass that to this function to call parameter in the getMovieData. If we save this and then we go ahead and bring this one up in our browser, now you can see that it's saying movie data retrieved, then getting movie data. And then, of course, since it passed a null in, the function to call is not a function, so we get an error. So you need to be careful with ensuring that you're using those parentheses at the right time. If you need to pass in data to your callback function, that's not a problem. Let's take a look at how we invoke a callback with an argument. In this HTML page, we're again calling this getMovieData, passing in a function called movieSuccess. You can see that on lines 45 through 47, where we're passing in some data. So it's expecting some data to be passed into it. And we're just going to JSON.stringify that data and put that out on the console window. If we then go back up to line 25, it's going to call getMovieData, passing in function to call. I need to create some data now to pass to our movieSuccess. So we're going to just create an object literal here with a movie object that has a film ID property, a name property, a genres property, and an actors property. And then we invoke our function to call, passing in that movie object literal. If we run this and we take a look, you can see that yes, indeed, the movie data did get passed down because it's being displayed on our console window. So now that you've understood how callbacks are called, let's now see how we can apply that to asynchronous programming. Well, first off, JavaScript is what's called an event-driven language. So that means that it can listen for and respond to events. This allows other code to run without blocking its single thread of execution. JavaScript is single-threaded, but the browser itself is actually multi-threaded. So one of these threads in the browser is used to manage an event queue. So when you add an event handler, like a button click, that code goes into the event queue. This is the start of asynchronous programming because we're going to be able to run code in the background while the user does other things. That's what asynchronous programming means. So if we can run things in a separate thread of execution within the browser, for example, that event queue, JavaScript can interact with that browser's event queue, and it can add to the browser's event queue using event handlers, the setTimeOut and setInterval functions, with callback functions, and with promises. So this is how we're going to start getting to asynchronous programming. What happens is JavaScript periodically checks that event queue for events that need to fire, any setTimeout or setInterval functions that need to be invoked, any callbacks that need to be invoked, or any promises that need to be fulfilled. Let's take a look at this setTimeout function. So setTimeout uses callbacks. So setTimeout, you pass in a callback function to execute after a certain amount of milliseconds has expired. So what happens is those milliseconds are saying, okay, let's wait right now for 3 seconds, but we're not waiting per se. What we're doing is we're giving this code, this function, to the event queue, and then we've told JavaScript single thread of execution, go ahead and go on with your work. Hey, but in 3 seconds, 3,000 milliseconds, let's go check that event queue and see if we need to run this function. So let's take a look at using the setTimeout and a callback. In this HTML page, down in the script, I'm going to call console.log, starting to run the script. I then have on lines 26 through 31 a setTimeout that has a function block right within that setTimeout. So that's the callback part that simply loops through from 1 to 5 and displays each of those index numbers on the console window. And that's going to be executed after 3 seconds. Then I've got another setTimeout that I'm passing in looping, which is a function that you see down here on lines 39 through 44. That one has a for loop that goes from 5 down to 1. And again, spinning each number out on the console window. So they're both saying 3 seconds. But remember, the code is going to run synchronous right now. So that first code block on lines 26 through 30, those are the ones going to be put into that event queue first. Then we come down here to line 36 and it says console.log script has ended. So the code from 22 to 36 runs, but then after 3 seconds it says go check the event queue. The JavaScript single-threaded process checks that and says, oh, I got this function that says let's index from 1 to 5 and display that. Then it says, oh, I've got another one that goes from 5 down to 1. So let's take a look at how this works. We'll open this up. We'll check our console window and look at there. Starting to run the script, script has ended. And then we get 1, 2, 3, 4, 5, a blank line, 5, 4, 3, 2, 1. Now let's take a look at this another way. Let's change this now to 2 seconds. So what happens by doing this is this one now says, well, after 2 seconds, I want to run this. So this one's going to execute first. So if we come back to the browser, we'll see that the 2-second one happened, and then 1 second later, that one that it increments has now executed. So there we go. A little example of some asynchronous code, because now things did not run synchronously, right? We got starting to run the script, and then script has ended. Then finally those 2 other functions ran because they were waiting to be run in that event queue, which is a separate thread of execution within the browser. Let's take a look at one more example of simulating asynchronous using a callback. In this HTML page, line 23, call get movie data, passing in movie success. That's my callback. And we can see movie success all the way down here where I'm going to ask it to pass me some data, and I'll do a console.log on movie data, and I stringify the data being passed in to be put out onto the console window. The next call on line 26, get genre data, passing in genre fulfilled, again a callback, and we can see that one down here on lines 66 through 68. So I'm going to again pass in some data that's going to be genre data that gets put out onto the console window after stringifying it. So let's take a look. Lines 28 through 43, I've got this function called getMovieData into which I'm passing that callback. Now, I'm also going to create a setTimeOut here. So after 2 seconds on this one that you see on line 42, it's going to execute this function where I'm going to do console.log, got the movie data from the API, and then I invoke the callback function, passing in a movie object literal. In the get genre data, again, it's coming in. I'm going to create a timeout, have a function block to execute after 1 second, and again, I'm going to call my callback, passing in some genre data. Now again, I've got a lot of console.logs in here so you can see the order of execution. Okay, so it's not going to be that straightforward. The first one that's going to appear is calling API to get movie data, calling API to get genre data. Then, since this one's 1 second and the one up here on line 42 is 2 seconds, we're next going to got the genre data from the API. And then finally, back up here on line 33, we'll got the movie data from API. Let's go ahead and run this. Open up our console window, and now you see exactly what I just explained, right? Calling the API to get movie data, call API to get genre data. So those two ran. Then after 1 second, we got the genre data from the API, and we put that on the console window. And then after 2 seconds, we got the movie data from the API, and that was then displayed in the console window. So you can see how we're able to simulate this asynchronous process by using these setTimeOut functions. You can pass as many callback functions you want to any other function. The most common use is to pass in one function that says when this function is successful, call this callback. Otherwise, if an error occurs, call this other callback. Let's take a look at that. In this HTML, on line 24, I'm going to call a function called getMovieData, passing in a 1 and then 2 function callbacks, movie success, movie error. Then on line 29, I'm going to call getMovieData again, passing in a 2, and then those same movie success and movie error callback functions. We can see those functions down here. Line 61 through 63, we have our movie success, where we pass in the data. We simply display that with a console.log on the console window. If an error occurs, I'm going to call this function movie error, passing in the error object, and I'll do a console.error on that error message. Let's take a look. So in the getMovieData function, getMovieData, I pass in the ID, a 1 or a 2, and then I pass in the function called resolve, that if everything is successful, we'll resolve this function and make that call. Otherwise, we'll reject. So resolve and reject. I then have created this movie object. And then down here on lines 48 through 57, I've got my setTimeOut that says after 2 seconds, invoke this function block, which says if ID is equal to 1, then invoke the successful callback function. So it calls the resolve, passing in the object literal. Otherwise, if that ID is not equal to 1, let's call the reject, and we'll create a new error object filling in the message property with invalid ID, whatever ID was passed in. So one of them does the console.log, one of them does the console.error. So let's run this and take a look. Bring up our console window so you can see the two console.logs for passing in a 1 for success, passing in a 2 for the error. The first one displays the movie data. The second one actually shows the error and the error message invalid ID number 2 passed in. Now, just so you know, callbacks are still used in JavaScript. However, it is preferred to use the new promises object. And that's what we're going to cover in our next lesson. In this lesson, we acquired skills for executing callback functions. We transmitted data to callback functions. We implemented asynchronous callbacks, and we provided functions for handling success and errors. Coming up next, implementing promises for asynchronous JavaScript.